All right, so here's the last lesson in this unit, and finishing off the work on solving rational equations. And the focus of this, as I introduced last day, is dealing with rational equations that will at one point involve a quadratic equation, we call, or an equation that has eventually two solutions most likely. And that's what I start with here. And these sort of ideas will become, the foundation of this course. And quadratic equations like these, is a key part of the course. And we'll look at this in a lot more detail later on. Right now, though, we don't need any more than what we've already learned. And so, for example, if I want to solve this equation on the left, x squared minus 2x minus 15, if I can factor this, I can just inspect my factors and see what the answers are, because it equals 0. And so let's factor this. What are two numbers that multiply to negative 15 but equal 0? Minus 5 and positive 3. So those are my factors. And again, how does that help me see the solution? Because if I look at the factored form, I know I want everything to equal 0. And I know I have one factor times another factor. And I know that once one factor equals 0, everything equals 0. So now I can just see by inspection, okay, I can see right here, one of my solutions must be that x equals 5. Because 5 minus 5 is 0. And once I have that, it all equals 0. And I can see my other solution must be x equals negative 3. Because again, negative 3 plus 3 is 0. And once one factor equals 0, everything equals 0. And so that's my solutions, negative 3 and 5. And if we can factor quickly, and we remember the simplicity of our 0 times tables, this is quite quick. This equation on the right. The only reason it's going to take a bit more time is because I can't factor it quite as quickly. I can't take out that factor of 2 right away, but I can factor it by first multiplying 2 and 3 to get positive 6. Think what multiplies to positive 6 but adds to 7? 6 and 1. Again, these aren't my factors yet. I want to divide each of these by 2. And now I can inspect these and see my factors. For example, my first factor must be x plus 3, because 6 over 2 reduces to 3. My second factor, 1 over 2 doesn't reduce, so I swing the 2 up, so I get 2x plus 1. Now that I've factored, all of this is equivalent to this. Now let me inspect this, and again, inspect my factors. Right here, I can see x must equal negative 3. That's one of my solutions, because I can just see negative 3 plus 3 is 0. A little less obvious about what to do for the other factor. What value of x would make 2x plus 1 equal 0? If you're not sure, well then be sure. Just write down 2x plus 1 and make it equal 0. And again, I'd subtract 1 from both sides, which means 2x must equal negative 1. Divide both sides by 2. X equals negative 1/2. So that's my other solution. And after a while, we can just look at this and get to that negative 1/2 really quickly. But either way, I should formalize my answer. So x equals negative 1/2 and negative 3. So I use factoring to solve what we call a quadratic equation. And why we call it quadratic doesn't really matter right now. We'll get to that later on in the course. OK, so now let's connect this back with what we were really doing last day, which was solving rational equations. OK, so again, the first thing I want to do is notice I have an equation, which means it equals something. There's a left and right-hand side, which means I don't actually have to deal with these denominators if I don't want, as long as I just multiply everything by the lowest common denominator. And in this case, the lowest common denominator I can quickly see is just x plus 1 times x minus 1. So I'm going to take everything here and multiply by x plus 1 times x minus 1. And yeah, it'll look a little bit messy. So x minus 1, x plus 1, x minus 1, x plus 1, and I have to do it to everything, or else it's not balanced. All right, so looking at my individual terms now. Yes, I know it looks messy, but looking at this, the x plus 1's cancel out. So all that's left is 2 times x minus 1. Over here, again, yes, it looks messy, but the x minus 1's cancel out. So all that's left is 5 times x plus 1. And the right-hand side, nothing cancels out. That's OK. So I have negative 6 times x plus 1 times x minus 1. And yeah, I don't have any denominators left, which means I can do a few things. I can distribute these. And here, I would actually just first write x plus 1 times x minus 1 as a difference of squares, and then I distribute the negative 6. So I get 2x minus 2 plus 5x plus 5 on the left-hand side. On the right-hand side, again, I can distribute the negative 6 if I want, but I would rather do this first. I'd rather go x plus 1 times x minus 1 first, because we've seen factors like that so often. I'm hoping we know that really quickly that must equal x squared minus 1. And then I distribute this. And the left-hand side, I might as well collect some like terms as well. So I have 7x plus 3 on one side and negative 6x squared plus 6 on the other. OK, now we can see, or start to see how this connects to what I was just talking about a few minutes ago. I got an x term and I have an x squared term. So I want to bring everything to one side. I want to make everything equal 0 if I want to take advantage of what I was talking about a few minutes ago. If I want factoring to be of any use, I need everything to equal 0 before I factor. Otherwise, I can't take advantage of the 0 times tables. And so I'm going to add 6x squared to both sides. I'm going to subtract 6 from both sides. So on the right-hand side, I now have nothing. That's great. I love that number. On the left-hand side, I have 6x squared plus 7x, and then plus 3 minus 6, minus 3. All right, and this is now what I want to factor. And if I can factor this, I'll see my answers really, really quickly. But again, to factor this, I don't have a, I don't have a greatest common factor of 6 that I can take out. So I probably want to multiply 6 and negative 3 to get negative 18, and think to myself, what multiplies to negative 18 but adds to positive 7? Positive 9 and negative 2 are what work. And again, there's a 6 here, so I divide each of these by 6. And again, these are not my factors, but I can use this to see my factors. And so looking at the first expression, first factor-ish thing, 9 over 6 reduces to 3 over 2. Swing up the 2, I got one of my factors, 2x plus 3. 2 over 6 reduces to 1 over 3. Doesn't reduce to a whole number, so I swing up to 3, and I have 3x minus 1, and all that equals 0. And like I've said many times before, how we exactly factor it, you don't have to use the shortcut that I'm using, as long as you're correct the vast majority of the time, and it doesn't take us too long. All right, so now I inspect my two factors. Looking at this one, 2x plus 3 must equal 0, and if you can't do that in your head, that's OK. Just write 2x plus 3 equals 0. It'll always be the same two steps. So after a while, I'm sure we can do this in our head. Subtract 3 from both sides, you get 2x equals negative 3. Divide both sides by 2, x equals negative 3 over 2, or negative 1.5. Looking right here, what value of x would make 3x minus 1 equal 0? If you're not sure, be sure, write it down. Just add 1 to both sides, divide both sides by 3. Now I can see my two solutions. So my two solutions are both fractions. Neither is a whole number. One is negative 3/2, one is 1/3. And so if I look at all the work here, again, very little of it had to do with rational equations. That was just getting past my first step. Most of it was, in this case, actually dealing with factoring and looking at my factors. All right, which leads me to my last couple questions, which it's hard to tell in advance how difficult they're going to be or not. But a lot of stuff going on here. But again, I don't have to deal with these denominators if I don't want to. And hopefully I can quickly see that x squared minus 4 is the same as x minus 2 times x plus 2. And so once I see that, I can see my lowest common denominator is x minus 2 times x plus 2, or x squared minus 4. And so I'm going to multiply everything by x minus 2 times x plus 2 right away. And yeah, it looks a little bit messy right here. OK, that's it. Don't get scared off, because again, I can see right here that this factor of x plus 2 cancels out. So all I have left is x minus 2 times 4x minus 1. OK, the next term, I can see x minus 2's cancel out. So all that's left is x plus 1 times x plus 2. And on the right-hand side, all of this cancels out with all of that, because x squared minus 4 is equivalent to x minus 2 times x plus 2. So all I have left is this. All right. Again, got past that first big hurdle, and now I can focus on this. So I now have a fair amount of multiplication work to do, combining, expanding, combining, all that sort of stuff. So let's look at these. If I FOIL this out, I should get 4 terms. I get 4x squared minus x minus 8x plus 2. Next, FOIL all this out. I get x squared plus 2x plus x plus 2. And the right-hand side I just copied out. All right, so now I'm going to start collecting like terms. On the left-hand side, let's get all my x squareds together. So I have 4x squared plus another x squared is 5x squared. Why did my marker get so big suddenly? The mysteries of the Apple Pencil. There we go. And hold on. Aha! I made a mistake. As I do, as we all do. There's a minus sign there. It's a plus sign here. Why is that? I don't know. It shouldn't be. It should be a minus. Doesn't affect this step. It definitely affects this step right here. So let me adjust. Right here, this should be minus, which means if I don't want to put brackets here, I need to distribute that negative. So maybe what I'll do though, and I'm glad I got that, is collect some like terms first, and then, I can distribute the negative right now, but maybe I'll just clean up what you see in green here. Let's collect some like terms here. I get 4x squared minus 9x plus 2 minus, right here, if I collect like terms, I have x squared plus 3x plus 2. And over here, again, I haven't really done anything with this in a while. Now I'm going to distribute this negative. And honestly, I feel a little bit lazy. So instead of writing this whole thing out, I'm just going to erase the brackets and change the signs here. There we go. And now I'm going to start collecting like terms. So there's a whole bunch of ways I can do this, but I'll do what I did before. I have 4x squared minus x squared. That's 3x squared. Right here I have minus 9x minus 3x. It's minus 12x. And then plus 2 minus 2. It's all gone. All right, so now let's bring everything to the same side. I'm going to subtract x squared from both sides. So now I'm going to add 4x to both sides, and so on. I need to make the whole thing equal 0. So I'll make the right-hand side equal 0. The left-hand side, what do I have? I have 2x squared. I have minus 8x minus 24. All right, now it's finally come together. Okay, I want to factor this. The first thing I should always check when factoring is not a difference of squares, it's checking for a greatest common factor. And there's a greatest common factor of 2 I can take out of here. Okay, and now let's look at this. And because I took out a factor of 2, if this is going to factor, I just have to find two numbers that multiply to negative 12 but add to negative 4. And those two numbers are negative 6 and positive 2. And now I can inspect my factors. I can see my solutions. X must equal 6, and x must equal negative 2. Kind of. Because if I now write down x equals 6 and negative 2, and circle it, and feel proud of myself, well, it's good. It's good. You should feel proud of yourself if you did this, but there's a mistake here. And it's not like the mistake I made before where I just randomly changed a sign. One of these answers doesn't belong. Well, that's annoying. So why is that? it's not like I can't look back. It's not like I'm going to find an algebraic mistake. There's a lot of work here. But the problem is, if I go back right to the very beginning, let me go back to the question at the very beginning, and let me erase all this stuff I wrote on here. Let's remind us what I gave you here. We're trying to find a value for x so that the left side equals the same number as the right side. So we've now said if x equals 6 or if x equals -2, I can replace all these x's with either 6 or -2, and the left side will equal the same number as the right-hand side. The problem is -2. Because if x equals -2, right here, you'll be dividing by 0. And in fact, also right here, you'll be dividing by 0. And so how on earth can you say the left side equals the same number as the right-hand side if you can't even evaluate for this answer? And again, we're saying -2 is one of our solutions. But the truth is, I can't even put -2 into this because -2 is one of our restrictions. And so the point of this question is that really, as soon as you're solving something like this, before you do anything, I would recommend you make a little note to yourself of what the restrictions are. In this case, I can see x cannot equal plus or minus 2. And so make a note to yourself, and then do all the work. And now, once I get to this step, just take a moment to look back to our restrictions and think, is one of these in my restrictions? Well, yes, -2 is. And so 6 is OK, but -2 cannot be one of my solutions. Because again, I can just see from the start that I can't actually replace x with -2 in most of these expressions. And so what do? It's not a big deal. We just cross out the -2. We say we reject it. Sounds kind of harsh, but we reject it again because of the restrictions. And so therefore, the answer is 6 only. I don't fault anyone for not thinking of that in advance, because until right now, this hasn't probably really ever come up, the idea that you can solve something algebraically, make no mistakes, and you'd have a solution that is extraneous, we call it, that's not actually correct. However, we will start to see it more in this course. And that's it. It's probably a fairly new idea so far. OK, so if I look at all the work here, most of it, again, did not have anything to do with fractions. Once I found my lowest common denominator, it's a matter of all this polynomial work here. And honestly, this connects, this kind of completes everything. This, I don't feel like dealing with that. It's very similar to what we did before, but yeah, I don't feel like it. I think we get the idea. And so I'm going to stop here.